Hello everyone, this is Zijun Lin from Physics 100, and here's my project of measuring reaction time. So to start this experiment, we need the following materials. First is a reaction strip. The strip is made by a strip of hard white paper, and I made some mark. I make the mark at each 5 millimeter on the strip. And we also need pencil and paper to record the data. And I use the Microsoft Excel to record the data and draw the graph after I done the experiment. I use the following equation to calculate my data, and the first one is h equal to 1 over 2 times g times t squared, and the second one is t equal to square 2h divided g equal to square h divided 5, and in all of the calculation I use the auxiliary gravitative equal to 10 meter per second square, so it will be easier to calculate. And here's the process of the project. First, I prepared all of the material for the experiment, and then I found 10 females and 10 male students to be the subject of the experiment. So for each one experiment, a person holds a hand side of the reaction strip and put the other end side stay between the subject's finger. When the holder relaxes her hand without warning, the subject needs to catch the paper strip as soon as possible. Then I'll repeat the same process 10 times with one person and do it with 20 different persons, 2 females and 10 males and 10 females. And I'm recording the data. So here is my timesheet strapped. So the picture from the left side is a whole view of the timesheet strapped, and the one at the left is the end of the time strip. So I put a little bit empty area there so people can have a place to put their finger. And the distance, each distance is 5 millimeter. And the right side of the paper is the reaction time. So here is a graph of equal time increment. To get this graph, I use the equation that distance equal to 1 over 2 times acceleration times reaction time square. Because we know the acceleration is a gradient acceleration, so it's constant, and we got the reaction time during the test, so we can calculate the graph. And this is a graph of equal distance. So we can say, so the longer distance has a higher reaction time. And in this graph, I use the equation reaction time equal to the square of 2 times distance divide acceleration. And here is the conclusion of all of the 20 people's data. So from this data, we can get the average of 20 subjects is 175.96, and the standard deviation of all subjects is 28/30. And here's all of the questions. So number 9, what was the difference for each subject in average reaction time with and without the extraneous stimulus? So the reaction time tend to be faster or slower than usual with a different kind of the external stimulus. For example, when the people is not really pay attention to the experiment, the reaction time will be slower. And when someone scares the people who is doing the experiment, the reaction will be faster. And the question 10, in your opinion, did the extraneous stimulus you use affect subject's reaction times? And it's yes. 11, question 11 is, can you come to a conclusion about reaction time of males and females when there are minimal extraneous stimuli?
It's 1 o'clock.
So there's not huge difference about reaction time between males and females when there are minimum extraneous stimuli. Um, but it's maybe also because if we wanna know if there have any effect when there have any extraneous stimulus, we also need to have the other situation constant. But here we only constant the gender, so maybe the result is not really um, not really uh, accelerate. And the 12 is, can you come to a conclusion about reaction time of males and females when there are extraneous stimulus? When there is extraneous stimulus except both male and females tend to react different than they usually do. And the 13 is, do your results have any bearing on the effects of talking on cell phone while driving? Discuss. I think it's dangerous to talk on cell phone while driving because driving can disperse driver's attentions and lead to slower reaction time, which is easier to cause a car accident. And then it's question 14. Imagine that you are measuring the reaction time of someone with an extremely slow reaction time, which is greater than 2 seconds. So the A is, would the current cardstock be suitable? Why or why not? So it will not be suitable because S equal to 1 over 2 times G times T squared. So if the time is greater than 2 seconds, the length of the sheet will not be enough. Because the length of the person, the length we need will be longer than 20 meters. And the B is, how might you measure this person's reaction time accurately. Um, so there has two ways. First, this person can do some training to improve his reaction time, such as sport like table tennis, so he can improve his reaction time. So we can use same the same paper strap. And the second way is we can change the process. So we can change the catching process of dropping strip to turn on a bell, and change the catching process to push a timing button. The time will be counted when the bell is ringing and stop counting when the button is pressed. And 15 is, imagine that you are measuring the reaction time of someone with an extremely fast reaction time, which is less than 0.1 second. So A is, would the current car stock be suitable? Why or why not? So it will be suitable because when t equal to 0.1 seconds, s equal to 0.01 times 1 over 2 times 10 equal to 5 centimeter. So the paper strap is enough to measuring the measuring. And B is how much you measure this person's reaction time accurately. So it's similar with question 14. We can change the catching process of dropping strap to turn on a bell, and and change the catching process to push a timing button. So the time will be count when the bell is ringing, and stop counting when the button is pressed. So here's my presentation about measuring the reaction time, and thank you for listening.